Hello everyone, I am going to work through your test 3 review. You can see I have it pulled up here, and I am going to start with question number 1. So question number 1 says, determine whether or not the distribution is a discrete probability distribution and select the reason why or why not. Okay, so you can see we have our random variables here. We have our probabilities here. So all of our probabilities have to be between 0 and 1. You can't have a negative probability. Also, the probabilities need to add up to be 1. So if you add those 3 probabilities up, 0.34, 0.29, and 0.37, you do get 1.0. So since those conditions are met, that means that this is a discrete probability distribution. So my answer is yes. All right, the reason is because you read through here, the probabilities lie inclusively between 0 and 1, and the sum of the probabilities is equal to 1. Alright, question 2. Flip a coin 13 times. If you get 8 tails or less, I will pay you $20. Otherwise, you pay me $134. Alright, so the number of trials is 13. We all know the probability of getting a heads or a tails is 1/2. The thing I believe that makes this problem so difficult is that it says 8 tails or less. So that means, you know, you could get 8 tails, 7 tails, 6, 5, 4, 3, 2, 1, or 0 tails. And we have to get, if we're going to work out this problem, this is an expected value problem. We have to figure out the probability of flipping 8, 7, 6, 5, 4, 3, 2, 1, or 0, or getting that many tails. And so to do that, it would be a lot of work. However, you can use a table to figure that out. So if I come over here to tables, and I go to the binomial probabilities, it said that I was going to flip the coin 13 times, so n is 13. And we know the probability of getting a tail is 0.5. So this column represents the probability of getting, 13 tails. If you scroll to the bottom, 13, 12, 11, 10, so on and so forth. And I believe that our problem said 8 or less. So what we can do is just take these values here. Let's take all the ones up to 0. If we take all those and add all of those together, that will give me the probability of getting 8 tails or less. So what you can do is, I believe there's a way, if I select the values, then I could just copy the selected values, and hopefully it copied all of those, not just that one. Alright, and now what I'm going to do, you can put it in a calculator. I'm going to pull up Microsoft Excel, because Excel, has calculators built into it. Everybody should have Excel. You can even download it for your cell phone if you have a cell phone that can run all of this Microsoft stuff. Anyway, so what I'm going to do is I'm going to put all of that stuff here. That's everything I had copied. Now, if I select all of this, which it was already selected, but if I select all of this, and then I come over here to the sum button, right here, if I click that, it'll tell me that it's going to go down one row down here. It'll put the total. So watch. So this right here, this is the sum of all of those. So that means this is the probability that if I flipped a coin 13 times, that I would get 8 or less tails. All right. And remember, for expected value, that's problem number 2. For expected value, we have to know the probability. That was 0.8666, and we say that times the amount of money that we would make in the problem. So it's probability times $20. All right, we want to figure that out, and then we want to take the probability of losing this, which would be getting more than 8 tails, so 9, 10, 11, 12, and 13. So either you can go back to that table that I was looking at, and you can add up 9, 10, 11, 12, and 13. Or remember, all of the probabilities in every column here have to add up to be 1, because the probability of something happening and the probability of it not happening is always equal to 1. So, you know, if I said 1 minus this, that would be the same thing as if I went back and added all of the values up for 9, 10, 11, 12, and 13 tails. It's going to be 0.1334. All right, and so when that happens, remember, we're going to lose money. That's what the problem told us. You pay me $134. So if you're going to lose money, you have to represent that with a negative. So that's a negative $134. Okay. And again, this is expected value. So you have to take the probability of something happening and how much you're going to make and multiply those. And when you multiply those together, you get 17.332. And then this is the probability of it not happening and how much you would have to pay in. When you multiply those two, you get negative 17.8756. Okay? And so to find expected value, that's equal to the sum of those two. So if we take the sum of these two values, we're going to get negative 0.5436. So what that would mean is that whenever I do this, I would lose on average 34 cents. So like if I did this over and over and over, I could expect every time that I do it, even if I win some, I could expect that over time, every time that I've done this, I'm going to lose 54 cents. Okay, and remember, if it's money, we have to round to the second decimal here. Okay. So you can see they already have my dollar sign there. I just have to put in negative 54 or negative 0.54. Okay. Step 2 says, if you played this game 877 times, how much would you expect to win or lose? Round your answer to 2 decimal places. Losses must be entered as negative. All right, so if we're going to lose, and I'm going to go back to that decimal, that 0.5436. So 0.5436. So, and I'm making it negative. So that's how much on average we're going to lose each time. If we play this game 877 times, let's say this times 877, then I could expect to lose this amount. Now, I will admit that sometimes these programs don't exactly do what they're supposed to do, because on this problem here, what they actually want you to do, instead of putting in the 0.5436, they want you to put in just 0.54. So I really don't agree with that, because I would rather use exact values at all times. But if I put in negative 0.54 and multiply that times 877, this is the answer they're expecting. Negative $473.58. So make sure on number 2, when you're working out your test, that you put in the rounded value for the cents. Okay, don't put in the 4 decimals like I did to begin with. Alright, so negative 473.58. Alright, on this problem, this person says that they have an extra ticket to a concert, and they're going to ask everybody to put their name on a piece of paper and put it in a basket, and then they're going to randomly choose a person, and then that person can go to the concert with them. It says there's 35 people in the class. So what's the probability, or what is your chance of being chosen? So it says round to 4 decimal places if necessary. There's only 1 out of the 35 that's going to be able to go. So that's simply going to be 1 divided by 35. Alright, I just need to round that, it said, to 4 decimal places. So if I round that to 4 decimal places, that's going to be 0.0286. Alright, this next problem says that you order some tablet covers and get an estimated date of June 1st through June 9th. You know you'll be out of town on June the 4th and 5th. You're a little concerned about the package arriving when you're away. Assuming the delivery date follows a discrete uniform distribution, what is the likelihood your package will be delivered while you're out of town? Round your answer to 4 decimal places. Alright, so between June 1st and June 9th, that's 9 days, right? If you're going to be out of town 2 of those days, then 2 out of 9, that's going to be the probability that it will be delivered while you're out of town. So we say 2 divided by 9. Alright, and it says again round to 4 decimal places. So that's just going to be 0.2222. Alright, now this experiment consists of tossing a coin and rolling a 6-sided die simultaneously. A 6-sided die is just one, a lot of people get used to the word dice because usually you roll more than one, but a die is just one of those. What's the probability of getting a head on the coin and the number 1 on the die? So the probability of getting a head on the coin, this is problem number 5. Getting a head is 1 out of 2. The probability of rolling a 1 on the die is 1 out of 6. So we have to multiply those, and we'll get the probability is 1 out of 12. So let's just say 1 divided by 12. Alright, and if I round this to 4 places, it's going to be 0.0833. Step 2 says, what is the probability of getting a tail on the coin and at least a 3 on the die? So a tail, the probability is 1/2. Then at least a 3, that means that you get a 3, 4, 5, or 6. So that's 4 possibilities, rolling a 3, 4, 5, or 6. So it's going to be 4 possibilities out of a total of 6 possibilities, right? So if I multiply those two, that's 4 out of 12, or if I simplify, that's 1/3. Okay, 1/3 is about 0.3 repeating. So if I rounded that to 4 decimal places, it'd just be 0.3333. A certain insecticide kills 70% of all insects in laboratory experiments. A sample of 11 insects is exposed to the insecticide. What's the probability that exactly 2 will survive? Alright, when I first worked this problem, I worked it the wrong way because I didn't read the problem close enough. This is a binomial problem, and so you do have to know the binomial probability distribution formula. But the reason why I messed up is because the problem tells you that it kills 70%, but then we're trying to figure out the probability that 2 survive. Okay? So if it kills 70%, that means that 30% survive. And since we're looking for how many survive, that's going to be the probability we're going to use in our formula. So the binomial probability distribution formula, you might want to look at your formula sheet for that. But it is, for this problem, remember, it says that we had 6 total insects, and the probability that one of those is going to survive is 30%, or 0.3. And with the binomial probability distribution formula, we have to say this combination, NCX, where X is the number we want to survive, and then we have to say times P, that's the probability of success, to the X power, times 1 minus P. 1 minus P is the probability of failure, of something not happening that we want to, or the opposite, I guess, of success. So we'd say 1 minus P, and then that has to be to the n minus x power. Okay, so, and again, the reason why I missed this when I first worked it out is because it gives you 70% kill rate for the insecticide, but it wants to know how many survive. So you have to use 0.3 for your P instead of 0.7. Alright, so that's going to be 11C2 times 0.3 to the second power, alright, because that's how many we want to survive, times 1 minus p is going to be 1 minus 0.3. 1 minus 0.3 is 0.7. And then that's to the n minus x power. So 11 minus 2 power would be to the 9th power. Alright, so you do 11c2. You can do that in your calculator, or you can do it out longhand. And then you're going to multiply that times 0.3 squared, and then multiply that times 0.7 to the 9th. When you do that, you should get around 0.199750. Alright, and our problem wants us to round to 4 decimal places. So, to 4 decimal places, that's going to be here. So 0.1998. All right. Problem number 7. Auto Parts Department sends out a mean of 8 special orders daily. What's the probability that the special orders sent out will be exactly 4? Alright, so this is going to be a different type of distribution. This is the distribution. Anytime you start talking about time, like 8 special orders daily, what's the probability that exactly 4 will be sent out? That is one that we're going to have to use this formula on. So anytime you start talking about mean time and things like that, you have to use this formula. E to the negative lambda times lambda to the x all over x factorial. Alright, where lambda, that's going to be your mean value of time, or your mean value that is used per day or per hour or whatever it says. So this one says that they usually send out, or they have a mean of 8 special orders a day. So our lambda is going to be 8. And then we want to know what the probability is that on a day they send out exactly 4. Okay, that's going to be our x. So if I plug those values in, this is going to be e to the negative 8 power, and then 8, because that lambda is the same as that, to the 4th power, because we want to know the probability that exactly 4 are sent out, divided by 4 factorial. Now remember, e is, if you remember that from college algebra, if you have an e to the x button, which all calculators, scientific calculators should have, you can see right here I have an e to the x. So if I type in a negative 8 and I say e to the x, you can see that's a really small number because it's times 10 to the negative 4. Then I'm going to say that times, and now I have to say 8 to the 4th power. So 8, and then in this calculator it's x to the y. 4 equals, alright, and then I have to divide by 4 factorial. So divided by 4 factorial equals, alright, and that's my probability. If this problem is like all the others, I'll round to 4 places. If I round to 4 places, then that's going to be 0.0573. Alright, a company produces optical fiber cable, mean of 0.5 flaws per 100 feet. What's the probability there would be exactly 2 flaws in 900 feet? This is another one of those average problems. We're going to use the exact same formula that we used on the last problem. The only difference is it tells us how many flaws there are per 100. And we have 900 feet of cable. So if we have 0.5 per 100, this is for question 8, 0.5 per 100, and we have 900 cable, so it's 0.5 per 100, and we have 900 cable, then that means that we're going to have, on average, 4.5, if we multiply that together, flaws per 900. Now we want to know the probability there'll be exactly 2 flaws. Okay. Remember, this 4.5, that's going to be our lambda. So this is going to be e to the, and in the formula there's a negative, so negative 4.5 times 4.5 squared divided by, and why did I square that? Because we want exactly 2. So that's 2. And then divided by 2 factorial. Alright. So we need to punch all of that in the calculator. So first you want to put in the negative 4.5, so 4.5 negative. And then I'm going to say e to that power, so that's e to that power, times 4.5 squared. So I'm going to have to raise it, that's the x to the y button, squared, equals, and then I have to divide by 2 factorial, divided by 2 factorial equals. Alright, so if I round this to 4 decimal places, that's going to be 0.11225. So 0.1125. So let's put that in. Alright. There are 8 black balls and 7 red balls in an urn. If 5 balls are drawn without replacement, what is the probability that exactly 2 black balls are drawn? Alright. So the problem with this is, it's not that we're just drawing one out, it's that we're drawing multiple out. And then out of those multiple that we're drawing out, we want to know, like, if exactly 2 black balls are drawn. So we don't want to know 1, or we don't want to know 0, or we don't want to know if all 5 of them are. That's what makes this problem a little tougher. And if you look on your formula sheet, you should be able to find that. And we're in the section on probability. So that would be chapter 6. I know the formula is in the ebook. It's also got to be here on your formula sheet. So yeah, it's this problem is a hypergeometric probability distribution. So the formula that we use for that is a little more complex. This is a hyperprobability hypergeometric probability distribution. It's K CX, so it's this combination times capital N minus K C little n minus x all over big N C little n. Okay. So in our problem, all right, since we're wanting to know a probability about drawing out these black balls. The K is how many possible black balls there are. So this is going to be equal to 8C, and then the X is how many that we want exactly. So of the 8 that are in the urn, we want exactly 2. Okay, so it's 8C2 times, and then the capital N, that's the number of balls total. So 8 plus 7 is 15. So we have to say 15 minus K. So 15 minus K, 15 minus 8 is 7. C, and then little n is the number of balls that we're going to draw out. So little n is 5, and then of course x again is the number of black balls that we wanted. So it's 5 minus 2, or 3, divided by, and then we're going to divide by the combination, the total number of balls, that's 15C, and then again, little n is how many we're going to draw out total, 5. So you have to work out this combination times this combination divided by this combination. You can do that in your calculator, or you can do it out by hand. But when you do that, you're going to get about 0.32634. I believe that, let's see, round to 4 decimal places. So we just want to put in 0.3263. Alright, this next problem, this is also a hypergeometric distribution. It says that a town is gonna, it says recently dismissed 9 employees. It had 7 employees over 50 years old and 18 under 50. If the dismissed employees were selected at random, what's the probability that exactly two were over 50? Okay, so we're going to use the same formula that we used on number 9. So we're wanting to know, we got a couple of key things in here, exactly 2. So that exactly 2, that's going to be our x. Now exactly 2 over 50, how many total were over 50? 7 were over 50. So that's going to be our k. So we start out 7c, and then we said we want to know exactly 2. So it's 7C2 times, then remember well, how many total did we have? We had 7 plus 18, we had 25. So big N is 25. So if I say big N 25 minus 7, that's 18. Okay, so this is 18C, and then little n, what's little n? That's going to be how many did they dismiss? They dismissed 9, so that's our little n. So we need little n minus x. So what is 9 minus 2? 9 minus 2 is 7. And then we divide by we have the total number, so that's 18 and 7, that was 25. C, and then again, what was little n? How many did they get, how many people did they get rid of? 9. So either do that in a calculator, do it out by hand, but whenever you do all of that, you should get 0.327122, so on and so forth. If we round to 4 places, that's 0.3271. Alright, so that's what we want to put in.